So sometime early this year, or like over the Christmas holidays, I was looking back at my complaints to, like if you go back in GitHub and Google my GitHub ID, you'll see like from my RDNA 2, when I got my GFX 1030, I was like, why is this thing not working? And then I'm like complaining about, oh, AMD should fix this software, or it should do tensile. I submitted some patch, and nobody, took a look at it because the focus was somewhere else, right? So I put this little thing out as to what would you like to see on Linux. And this is still, the most active poll on ROCm. And obviously, you get a good view of like what the community feedback is. So number one, what I'd like to do is first listen, and two is acknowledge, right? So what I wanted to do here is just like, yes, we have all of this awesome hardware, and we have all of these complaints. And this is just a small subset, right? It's like, me, Stella, in our team, we went through every one of those comments there, right? And I think there was just 1K votes there, but we internalized every one of those comments there. And that's just not the only thing, right? Like we are, I'm personally like listening to Reddit posts, Phoronix comments. So we do want to take it seriously. Obviously, we are a small team. We want to do the right things. And it's step by step. We want to do what's right. So we can't obviously just do everything, and you're never going to get there. But we get a theme as to what we want to invest in, right? And we want to invest in developers. So that is very clear. And so what have we done since all of this happened? And all of this feedback that we've gotten, right? And by the way, this is just not just this feedback, right? Like we've gotten feedback from good articles, like Dylan has written, there are others have written. So we internalize that, and we want to make sure we are responding to our developers. So with that said, let's start with source, build, CI. So there's a project that we started called the ROC. I don't know how it got named the ROC. It's supposed to be an acronym. You can go to the GitHub link and figure out what it is, right? And again, this is like another 30-year-old imagery that only I think 4 or 5 people get it here, but it's okay. It dates my movie-going era. But what we have done is, for the first time, we are getting a very, very clean ROCm build system, right? And what we want to do with that is git clone, CMake, and boom, you have everything you need to unlock the AI hardware, right? That is our goal. Of course, there's a journey in the process. We have gotten MI300 support, GFX 1201 with the Navi 9070s is demoing out there with Comfy UI. That was built with the ROC. But we expect this to accelerate, right? And some of this comes from like what we did in the Chrome OS days. Every 6 weeks we released software. At that time, that was like crazy. This is like 15 years ago. So we want to get to the same cadence of like, oh, if you find a bug, submit it. The CI will check it out. You get try bots, you get pre-submits, just modern OSS software development. So we're going to invest very, very heavily in that. And the key to that is, we provide the infrastructure so that you can also participate in, scratching the itch, right? Like, any Radeon 7 users over here? There are a few that want Radeon 7 support. They just love that card, right? And so we want to give you all of that ability. We may not be able to support it, but at least the community has a common watering hole for, for everything ROCm. Second, we're bringing internal and external developers to the same footing, which means a bug that you file is what our internal developers are going to see. A bug that they file is what you're going to see. So that gives you a transparency in development, right? Again, we want to go real to the fundamentals of how open source projects are run. And then we are building a Radeon lab. Again, like I mentioned, the feedback that we got, people love their Vega Pro something, right? And people just love those cards. So one of the things that we're doing is we obviously can't support every one of them, right? We've built so many cards in the past 20 years. So the past 10 years of cards, Chris over there, is somewhere here, is, he's at the back there by the demo, has a Radeon lab that literally has the last 10 years of AMD cards. So if a build is broken, you want to add a test, you want to do something, by all means, as long as you don't break other things and everything else passes, let's get it in, right? So we want to be able to retroactively get our software system to a point where you feel good about the investment you made 10 years ago. I still have my MI25 and my MI100, which is one of the reasons why I'm doing this too, right? I can use those cards. The other thing was like people with laptops, the Phoenix laptop, the 1103, they'd been complaining about it. Just this morning, I was able to check out the code, get HIP plus LT to build for 1103, 1150, 1151, commit the code. It's running through the CI, and I think it's merged, or it should be merged by the time we have this presentation. So it is actually hackable. If I can submit a PR for ROCm, you guys are going to be doing wonders with it, right? And we are making it Windows clean, so it's not a downstream, bolt on something, and it's going to have Windows support as an afterthought. There's a lot of work to do in that realm, but if you go back into if you go to the ROC and look at the actions, we're already building most of the Windows components. So we want to get it, again, going back to the way we did Chrome and Chrome OS and ship to 2 billion users, we want you to be able to focus on what you want to change, right? Like HIP plus LT, you want to make it more performant. SDPA, focus on those things. The fact that it runs on 10 different cards and it runs on 2 different operating systems or 3 different operating systems, no problem at all. There was a startup that wanted to do an ARM-based CPU and MI210. The ROC is just spin it up and run it. It's just normal CMake and cross compilation, right? And if there's any fix you want in there, just submit a PR. We'll take care of you. And then 9070, I think there's a demo out there that's running. Give it a try. Again, the artifacts for all of that is available. Those who need it can start playing with it. The way we are approaching ROCm is it's early. We're going to release early, release often, break it, fix it, revert it. Good open source ethos. But that doesn't take away from the fully validated ROCm that we release for production in our large data centers, 10,000 GPUs plus, right, or 100,000 GPUs. It is still work in progress. Go check it out. Contribute, do what you have to. It's there for your taking. I'll stop there for a second. Any thoughts, questions before I go into my next slide? Nope. OK, good. Oh, all right.
So one of the questions I have is that how to use the Docker images. One of the challenges I'm facing right now at our startup is that our Docker images are extremely huge.
Yeah.
So how to reduce that size?
Oh, very, very, very good question. So we are going de-Dockerizing everything. So if you look at that build command I gave you there, you don't need Docker. It's fully de-Dockerized. You'll get a ROCm wheel package and a PyTorch wheel package. So it distills it down to the essence of what we need. So there's no crap coming in from Docker. The convenience and the thing with Docker is that you can easily accumulate cruft, and then that adds up because you don't know what went in and it's not in source control. So what we're doing with the ROC is pulling it all the way up to the build system, and then we are doing some advanced packaging tricks to do late binding of architectural, loading of binaries, to the point where it's still experimental, so I don't want to oversell you on it, but it gives you the benefit of having a optimized library per architecture, but the ability to like load packs of those architectures only for the architectures that you need, right? And then merging that with wheel next and that kind of packaging, you get the ability to like get really lightweight deployments.
So if I understand correctly, I don't need to use the base image of ROCm, and I just take the plain vanilla Ubuntu Docker image and then build the CI and then use it.
You don't need the Docker image. So that demo that's running there, my laptop over here is actually a Framework 13 that can build all of ROCm, and that's my primary laptop.
What if I want to use Docker?
Oh, by all means. Yeah. So it's optional, right? And if it's convenient for you and you want to do isolation, you want to use Churoots, you want to use Docker, Podman, LXD, whatever you want, you can do that. But the simplest way is git clone, cmake, and you're done. That's what we want to get.
Would this work with a heap and also with PyTorch?
That's right.
Okay.
It's functional today. So right now, and if you are not hacking on it and you just want the latest binary, just go click on it, and there's a CI artifact tree that has binaries for all those. And like I mentioned, 10 years of GFX hardware, we're going to put those binaries up. If it's broken, we may not have the test for GFX 806 or something, right? Let us know how it's broken, file a bug, give us a report. We'll work with you to make sure it's fixed. But we want you to feel included with the investment that you made in the past. You have another question? Yeah.
Oh, thank you. Yeah, thanks for all the work you put in this. I just want to second a bit again on the importance of the containers as well. Indeed, the Docker image size is pretty painful thing. And you're right, you don't often need that, but as soon as you want to run it in a data center on the cloud, there's no other choice. There's just no way. And that's why for development, you spend like, I don't know, 90% of the time actually doing development. And for development, you actually need to make sure that it's run in container, and actually image size is, yeah, pretty painful. Would love that to be improved. Thank you.
No, thank you. Like I mentioned, I think, there are 20, 30 gigs, and some special Docker is going to 80, which is not acceptable. Our target is like a 4 GB one, right? And it's in the process. Like I said, there's some more in terms of how we do packaging, how we do late binding of architectures. And it gets it to a point where the advantage of what, shipping a PTEC level thing for CUDA is no longer an advantage, because we're going to, there is no need for a PTEC to SAS in the last mile, because we're going to generate AMD GCN directly. But the only disadvantage is that right now, it just increases size. But if we have an ability to like late bind those, then it gives you the ability to get the benefit of like going down straight to the machine architecture, which is again open, right? Like you can do whatever you want with that. Cool. Any other questions on this? Yeah.
So given that desire to have more people go straight down to the architecture and really contribute there, does that mean that there's also going to be a greater amount of documentation for the microarchitecture, things like latency tables, things like issue instruction mixes, things like being able to access the onboard DMA engines?
Yeah. So I'd peel that into a few different parts. Documentation, 100%. Ramin, who's walking out there, owns documentation. He's hiding. So you can get him. But if you don't have any documentation, you should reach out. And the thing that we do really well is ISA level documentation is, the moment the card hits, like RDNA 4 hit the market, it was there. There's no ifs, buts, etc. Right? Like you go to GP Open and you get it. There are, like when you get really, really into the weeds of how you're doing loads and stores and latencies and things, it is a competitive market. We are an underdog, right? So you should, view it with that lens too. Like we have opened the ISA, but at the same time, it's a yearly cadence of hardware that we're churning out, right? So it gives us the, we have to execute and be competitive, right? So there's one or two things here or there that when you get to that level, email me, and I will make sure you find what you need. Yeah. Any other questions? Okay, let's go. Yeah, performance. So we talked a lot about all of this, making it. Oh, sorry, we have a question. Sorry, yeah, go ahead. Let's see if the back button works. Oh, by the way, this rock is the Alcatraz rock for those who don't know, and it's right there.
Yeah, actually, it's perfect. I'm going to ask a question about performance, actually.
Okay, you see the future. Okay,
Yes.
ask your question, and then I'll show you my slide.
So I was wondering, I mean, AMD definitely built a great hardware, and I just wondering what's the roadmap from actually bringing some kind of compiler optimization that is a kind of on par with CUDA, so that save my ass from writing assembly directly for all my code.
Yeah, I think there are two parts to it. Being an open ecosystem player, we want the best compiler people to generate compiler code for AMD hardware, right? And that means AMD itself is making an investment. I came to AMD through an acquisition from Nod.ai. We did ML compilers for like 6 years. The modular folks are right here. You can talk to them. They're working on AMD hardware, compiling awesome, binaries from Mojo, and they're giving a path down to that. There are other compiler technologies and companies. We work with the likes of CentML. Obviously, Triton is a big, big investment. We are 100% committed to Triton and making sure the Triton language is a great equalizer for exactly what you pointed out, right? You don't have to write legacy CUDA code. Right now, there's still a nostalgia of like, there's the latest model. They dropped down to PTEC, and it's like, cool, that's awesome. That's always going to be there, right? So if you rewind back to like the 80s and 90s of CPUs, the glibc memcopy was always a ASM instruction, right? Like it's an inline assembly or it's an assembly instruction for a memcopy, until it got to a point where the compilers were able to do it. And now your glibc is like maybe 5% assembly, or maybe even less than that. It's like 1% assembly, right? Because your compilers have been able to catch up. For machine learning and accelerators, I don't think we've reached that maturity with compilers, and we will get there. But if you listen to the OpenAI, the Triton talks, I think you get like 80, 90% of the performance. And sure, if you get to the next 10%, you need the next 10%. There are various options, including dropping down to the ISA. Cool. Any other questions? If not, I'll. Yeah, this is just literally this came out this morning, or is coming out this morning. We are not just committed to making ROCm accessible, usable, hackable, and ownable. You own it. You own every piece of the software stack, right? We want to make sure it's performant. And we are spending a lot of time in making sure that we are ahead of the game. This is still not yet published in probably next few days. We run it through a very, very rigorous internal benchmarking and methodology. So it takes a week or two before the data gets out, mostly because we just want to dot our I's and cross our T's. But it is a Formula One race, and we are in it to win. And we will be committed to make sure that performance is on par or better than what you see with competitive hardware. And I'm sure, next week you're going to see one big chart that goes through the roof, and everyone, is going to be like, I don't know how it's like, 400x faster than the last generation. But, when you boil it down to gen over gen, actual what rubber meets the road, we want to move, brick by brick. We want to just like get that data out. And this is not data that's like hidden behind some wall. There'll be a Docker that's released, right? So part of our release strategy, even before the ROC is being productized, is to get a weekly Docker with inference or biweekly with training, so you continually see these improvements. So just like a Formula One race, there may be a lap, someone's ahead, someone's behind, but we are committed to the long-term, the long race in this. Cool. I think that was all I had. Yeah, okay. And of course, 100, framework. We have a partnership with the framework folks. There are about 100 there they are with the hat, and there you can talk to them. I'm not kidding. Like I gave up my M4, whatever, 128 gig thing, and now I just use the framework as my primary. I know it's like selling a thing, but it really is pretty awesome. So if you guys want, go check that out. There's, I think there's a QR code you can scan to enter the developer contest or developer, you'll get a device. That's how, I know what it's called, but something. But there's 100 of those. And the good thing is we're going to give you full ROCm support, right? And so what you develop on that is what you can port to an MI300 or MI325 or MI355. So AMD has this wide portfolio, and increasingly the software ecosystem for you to move from a laptop to a desktop to a gaming rig to the Instinct data center should become seamless. The fact that they have different architectures, they have an NPU, they have a RDNA card, they have a CDNA card, is when you get to the last 10% of performance. Everything else should be seamless, and it should just work for you. OK, I think, that's all I had. And now we started the agenda. OK, with that, I'm going to give, I think I took my time.